Okay, so what we're going to do is we got a parabola here, and I know it's a parabola because what we're dealing with is the standard form. I got two different equations that I can have for parabola. I can have a y minus k is equal to 1 over 4p x minus h squared, or I could have x minus h is equal to 1 over 4p y minus k quantity squared. So what's got the square? The x has got the square. So what that means is, which one of these equations does the x have the square in? It's this guy. So I know that's the equation I'm working in. So I'm going to go ahead, and I know I need to get y by itself. And this is when you see this type of problem, this format where it doesn't have the parentheses squared, I know I have to complete the square. So I'm going to go ahead and take the x squared. I'm going to rewrite it here. And I know I need to complete the square for this guy. So I'm going to take this whole piece, I'm going to move it to the other side. The reason I'm going to move this to the other side is because then this will stay positive. I don't have to work with a negative, and that's going to be actually a lot easier. So when I move the 6y and the 8 to the other side, everything is going to become opposite. So I have a negative 6y minus 18. I'm going to complete the square here. So I take the middle term, divide it by 2, and square it, which is 9. And I'm going to take that and add it to the other side. I'm going to factor what I have on the left, which is x minus 3 quantity squared, and I'm going to go ahead and add these two guys together, and I get a negative 9. So now the other idea is y is all by itself. So I need to go ahead and get y all by itself. So in order to do that, I got to divide by negative 6. And what I do to one thing, I got to do to everything else. So I divide that by negative 6. So then that means we have this 1 over 4p. So the 1 over 4p is usually in this area. I'm going to go ahead and actually erase this real quick. And just change the color. We have this 1 over 4p. Well, that is this negative 6 here, basically. So I divided by the negative 1/6. So I'm going to rewrite this as 1 over negative 6, which is the same as dividing by negative 6. These guys would cancel out, and we'd get a positive, and both are divisible by 3, so I'd get y plus 3 halves. So I now have my equation. So given the equation, let's go ahead and label the vertex, focus, and directrix. So I know that my vertex is going to be 3, and we got to be careful here. It's going to be negative 3 halves. It's opposite of this because we've got to solve for y. Okay, so I got 3 negative 3 halves. What's p equal to? So I got to take this 1 over negative 6, set it equal to 1 over 4p, and cross multiply. Okay, so when I cross multiply, I get 4p is equal to negative 6, so p is equal to negative 6 over 4, which is negative 3 halves. Okay, so I got my vertex. I'm going to go ahead and plot that, which is 3. So 1, 2, 3. Negative 3 halves, so that's negative 1.5. So I plot that point. Does this guy open up or down? So let's look over here. It's a y is equal to, and it's negative. So that means I open down. So I'm going to draw my parabola. It opens down. And I know p is equal to negative 3 halves. So I'm going to go ahead and I'm going to move down 3/2, which is 1.5. So if I kind of look at this, I'm going to zoom in a little bit here. I'm going to go ahead and I'm going to move down, well, down here's a half and here's a whole 1. So I'm going to go ahead and plot this guy right there. And I'm going to do the same. So this is my focus. It's inside the parabola. I'm going to do the same backwards. So I'm going to move a half, which would be right here. I'm going to move to another half. I'm going to just plot a point here. It's not a point, but I know that that is going to be my directrix. So then I can look at this information and find what I need. I can label things. So I knew my vertex was at 3, -3/2. And I know that my p-value is also -3/2. So if I take -3/2 and add another -3/2 to that, that means my focus is going to be 3, -3. I'm moving 3/2 down from the y value, and I'm moving backwards 3/2, so that means my directrix, I look at where I graphed it, is y is equal to 0. And one thing that we haven't done in a lot of the videos is graph the axis of symmetry, which is the line that's perpendicular to the directrix. So the axis of symmetry, and I know I didn't ask for that in the problem, is whatever my x value is for that problem, for that equation. And that is how I would graph it. And the biggest thing here is using the completing the square process to solve this problem.